Hey, so this is my day 1 update. Let me walk through this in very simple way, not just what we are doing, but why we are doing it. And also I'll show you visually how it's happening. Let's start with set matrix zeros. So, imagine a grid of numbers. Now the task is simple. If any cell is 0, we have to make its entire row and column 0. Now let's say, why can't we just do it directly? Because if we start changing rows and columns immediately, we might overwrite values that we still need later. So we kind of lose information. So instead of doing that, we split it into 2 steps. First is marking and second is updating. So in first pass, we just scan the matrix, and whenever we find a 0, we don't change anything, we just remember it. Okay, now the question is, where do we remember it? We reuse the same matrix. Okay, we take the first row and first column and use them like a marker, like a reminder system. So if matrix ij is 0, we just mark matrix I0 and matrix 0j as 0. So there's one small issue here. First row and first column overlap, so we keep one extra variable for first column. Now second step is actually applying the changes, but we don't go from top, we go from bottom right, because we go from top, we might accidentally override our markers before using them. So we from bottom, we just safely update everything based on those markers. Okay, and at the end we separately fix the first row and first column. So pretty much it's just 2 passes. First pass is marking and second pass is updating. So the time complexity is bigger of m into n and the space complexity is bigger of 1. Now the next problem, Pascal's triangle. So here's the idea. The idea is actually very simple. Each row starts and ends with 1. Now the middle values, they come from the previous row. Okay, each value is just the sum of values directly above it. So instead of thinking formula, we just think let's build it step by step. We start with one row, then we use that row to build the next row, and we just keep on repeating this process. In code, pretty much we first create each row filled with ones, and then we only calculate the middle values using the previous rows, and each row becomes the base for the next one. So the time complexity is big of n square and space complexity is also big of n square. Now next permutation. So this one is actually interesting. We are given a sequence and we need to find this next slightly bigger arrangement, not random bigger like the next closest one. So we scan we scan from the right side because the right side changes faster. Okay, we find the first place where order breaks, that's our pivot. Now from the right side we look for the smallest number which is just greater than pivot, then we swap them. Now the right side is not still in the best form, so we reverse it, so it becomes the smallest possible arrangement, and that's it. So steps are simple: find pivot, find next greater element, swap, reverse effect. So the time complexity is bigger of n and the space complexity is also bigger of n. So that's pretty much about it. See you in the next one.